In the previous lesson, we just looked at sequences. Now we're going to look at a specific type called arithmetic sequences, and then we're going to look at what's called the series associated with the sequence. A sequence is just a list, but an arithmetic sequence is where the difference between each term is always the same. What did I do? I added 3, added 3, added 3, added 3, so I could get 17, 20, 23, and keep going. That's an arithmetic sequence when the difference between them is the same. And we call that difference D. That's the common difference. And why is it called difference? Is because you take those two and subtract. Take any two and subtract, and you subtract the term on the right minus the term on the left. We also have a recursive formula, and as we learned in the last lesson, that's just a formula that's in terms of the previous term. And again, D is that common difference. But that's not usually the most useful formula. We usually have that nth term formula, much more helpful, and so that's something we really need to know, where the A1 of course is the first term, n is the term number, like what place in line. Remember, n is also our domain. It starts out with positive whole numbers, 1, 2, 3, 4, 5. So if n is 5, that means it's the fifth one. So in this case, let's see, the fifth one would be 14. That means A sub 5 is equal to 14. And of course that D is the common difference. A series, the sum of a sequence is called a series. And for an arithmetic series, we have two formulas that will give us that sum. This first formula says if you have however many terms you have, divide it by 2 and multiply it by the sum of the first and the last term. That's the formula I like to use most often. But another formula is this, and it just comes from substituting a sub n with this formula up here. Looks a little bit messier, but sometimes helpful. Now that we have some formulas, let's just kind of go through and apply those formulas. It says find a formula for the nth term given a sub 1 is 6 and d is negative 2, and this is all for an arithmetic sequence. So I want this formula here, a1 plus n minus 1 times d. I want a formula for the nth term. Well, let's see. a1 is 6, n is n, and d is negative 2. So that is a formula, but let's clean it up a little bit. So we have 6, and let's distribute, minus 2n plus 2. So that would be 8 minus 2n. That would be my nth term formula. Does it get harder? Well, of course it does. All right, so we're not finding a formula here. They want us to find the 80th term of that sequence. So I want a sub 80. So going back to my formula, what do I need? I need a1, I need n, and I need d. So a1 is the first term. N is what place in line? That's 80. But I need my common difference. What did I add to each term? 2. That's pretty easy. So the 80th term is the first term plus n minus 1 times d. So let's see, that's 79 times 2. And I get 157. So you could write out all 80 terms, but it's much easier if you just use the given formulas. This one's a little bit tougher maybe. We want to find the first term, the common difference, and the nth term. If the 8th term is 4 and the 18th term is negative 96. Wow. So it says the 8th term is 4, but the 18th term is negative 96. Well, that doesn't tell me D. It doesn't tell me a whole bunch. So I need to kind of work backwards. So remember my formula? Well, let's take this and apply it to there. So n is 8. I don't know the first term. And again, what is n? It's 8. And I don't know the common difference. So I'm going to write it like this. A1 plus 7d. But wait a minute, I think I know one more thing. I know what a sub 8 equals to. So I can replace that with what it's equal to. 4. I know that's not helpful, but that's what I've got. All right, let's do the same thing here. I know the 18th term. Let's see, A1, that's 18 minus 1 times D. But again, what is the 18th term? Negative 96. So I can write that as negative 96 equals the first term plus 17D. That's what I've got. I've got two equations, two unknowns, and I need to solve for A1 and D so I can write my nth term formula. So I'm going to use the elimination process, meaning if I take these two equations and I line them up just like they are, I'm going to add them together, but if I just added them together, nothing's going to cancel. So I'm going to subtract this one. So it's going to change all the signs. So that's going to become positive, negative, negative. And then if I add these up and down, that's 100. That cancels, and I have negative 10d. So d is negative 10. Then I'm going to come back up here and substitute that in to solve for A, or A1. So that's negative 70, add it to both sides. So the first term is 74. So my nth term formula would be this. I could clean it up a little bit. That'd be 84 minus 10d. And then you could check it out. Let's see, if I put in 8 for n, 10 times 8 is 80. 84 minus 80 would be 4. Then you could put in 18 and you would get the answer. So here we're putting together a system of equations and solving for the two variables that we need. These last two examples ask us to find the sum. So the sum, we have different formulas there. That's my preferred formula, so I need n, a1, and a sub n. Well, those dot dot dots tell you there's some missing terms in. So I believe the first term is 7. That's pretty easy. I'm not worried with d, that's not anywhere. I need to know n and a sub n. Well, in this case, we're going to take a sub n to be negative 299. That's the last one I need to add up. But what is n? I don't know. So then I'm going to go back to this formula. Well, if a sub n is negative 299, and my first term is 7, but I don't know n, what's d? Did I add? Did I subtract? I believe I subtracted 6, so my common difference is negative 6. So this is what I need to solve for n. So I'm going to subtract 7 from both sides. And yes, you could distribute the negative 6, but I think I'm just going to go ahead and divide by negative 6, and I'm going to get 51. So n is 52. So now I can get my sum, 52 over 2 times 7 plus a negative 299. So I have 52 divided by 2 multiplied by 7, and I'm just going to say minus 299. And I get negative 7,592. So my sum is negative 7,592. So we're using our formulas to figure out the sum of a particular arithmetic series. Ooh, we have that sigma notation. Again, we find the sum. But let's just verify that that is arithmetic. It certainly is because it's in this section, but let's just verify that. So let's just write out a few terms. So that's 1/3 plus 1/2. Then if I let n be 2, that would be 2/3 plus 1/2. And if I let n be 3, and of course I would keep going to when n is 80. And I certainly don't want to add all those up by hand, but if I did, let's see, this is 5/6, that's 7/6, and the next one would be, I believe, 9/6, and keep going. So is that arithmetic? Yes, it is. I'm adding 2/6 every time, and 2/6. So what is D? I'm adding 2/6 or 1/3. So that's my common difference. But my sum formula, I don't think has that. So n tells me how many things I want to add up. Well, if I start from 1 and I go to 80, how many is that? That's 80. And since I wrote it out, that's my first term, so that's 5/6. And then my last term would be that. So let's see, if I found a common denominator, that's 163/6. So I have 40 times 168 over 6. So 40 times 168 divided by 6, 1,120. So yes, you'll need a calculator. It is quite helpful. An arithmetic sequence is a list where you have a common difference that stays the same. The series is just the sum of that sequence.